Okay, let's dive right into this explainer. We're looking at the ultimate irony of our blue planet, why a world literally covered in water is somehow rapidly running dry. It's a massive puzzle. And today, we're going to unpack exactly what's happening to our most precious resource. You already know the basics, right? Roughly 75% of the Earth is water, and land is just 25%. But here's the real kicker. Only a tiny fraction of all that blue is actually usable, renewable freshwater. And most of that comes from surface runoff and groundwater, which gets constantly recharged through the hydrological cycle. Which brings us to our core paradox. If nature is constantly recycling our water for us, theoretically making it a renewable resource, why are billions of people on the brink of absolute scarcity? I mean, how is it predicted that by the year 2025, nearly 2 billion people won't have enough water to meet their basic needs? To figure this out, we're going to follow a clear path today. We'll look at the water scarcity paradox, the actual causes of our thirst, the promise of large dams, the problem with those big dams, and finally, some really clever rainwater harvesting solutions.
So, part 1, causes of our thirst. Why exactly are we running dry?
Well, the most crucial thing to understand is that water scarcity isn't just about living in a desert. Sure, we often picture someone walking miles with an earthen pot, but scarcity is hitting modern, rainy cities hard too. Why? Mostly because of overexploitation, terrible mismanagement, and unequal access. Plus, even when water is theoretically abundant, it's often so polluted by domestic waste, industrial chemicals, and agricultural pesticides that it's just totally hazardous to use. The pressure is literally coming from all sides. We've got a booming population that needs more water for homes and, crucially, to grow more food. To get that food, farmers are heavily overexploiting groundwater for dry season irrigation. Then you add in intensive industrialization, massive corporations needing vast amounts of fresh water for processing and hydroelectric power. And finally, you have these multiplying, incredibly dense urban centers, rapidly draining whatever fragile groundwater is left with their own private pumping devices. Moving on to part 2, the promise of large dams, and how we tried controlling the flow. For decades, humanity basically tried to engineer its way out of this mess. Right after independence, leaders placed immense hope in large dams. Jawaharlal Nehru actually called them the temples of modern India. And you can see why the vision was so powerful. They believed these massive structures would perfectly integrate agricultural development with rapid industrial and urban growth. These structures, like the Bhakra Nangal or the Hirakud project, are called multi-purpose projects because they don't just hold back water for later. They are massive engines for regional development. We're talking electricity generation, irrigation, flood control, industrial water supply, and even inland navigation and fish breeding, the whole shebang. But part 3, the problem with big dams. Let's look at the unintended consequences. While they definitely provide undeniable economic benefits, these massive interventions fundamentally alter the natural flow of rivers, and that causes a domino effect. You get poor sediment flow, which makes stream beds rockier and completely disrupts aquatic habitats and spawning. Plus, they submerge vast areas of land, displacing huge numbers of local communities. They even spark fierce interstate water disputes, like the Krishna-Godavari dispute, which was all about one state diverting water and reducing the downstream flow for everybody else. But honestly, here is the most ironic engineering flaw of all. Dams built specifically to control floods have sometimes actually triggered them. Regulating the river causes massive sediment buildup at the bottom of the reservoir, which physically reduces its capacity to hold back heavy floodwaters. So during extreme rainfall, they fail. And to make matters worse, all that trapped sediment deprives the downstream floodplains of natural silt, which is an essential natural fertilizer. Which brings us to part 4, rainwater harvesting solutions, ancient wisdom, modern fix. Given all the massive ecological and social headaches of megadams, a lot of people are looking backward to move forward. India actually has a millennia-old tradition of incredibly sophisticated hydraulic structures built specifically for local ecosystems. As far back as the 1st century BC, Srinavarapura had systems channeling Ganges floodwaters. By the 11th century, they built the massive Bhopal artificial lake. And in the 14th century, the house Khas tank was supplying Delhi. Our ancestors really understood rainfall. And that ancient knowledge translates into brilliant local techniques today. In the arid regions of Rajasthan, households capture what they call polar pani, basically the purest form of natural water,
using this super effective rooftop system. Rain hits a sloping roof, travels down PVC pipes, gets filtered through sand and bricks, and is stored in huge underground tankas right in the courtyard. They even build underground rooms next to these tankas because the stored water keeps the adjoining rooms nice and cool during the scorching summer. How smart is that?
Or take the mountainous state of Meghalaya, where farmers have been using a bamboo drip irrigation system for literally 200 years. They tap spring water into these bamboo pipes, let gravity carry it over hundreds of meters, and the flow is reduced to just 20 to 80 drops per minute right at the plant's roots. It's just an absolute marvel of efficiency.
Now, consider the wild situation in Shillong, Meghalaya's capital. It's just 55 kilometers away from the absolute wettest places on planet Earth. Yet, the city itself faces acute water shortages. Because of this, nearly every household relies on rooftop rainwater harvesting, supplying up to 25% of their total water needs. It just goes to show that smart, local harvesting is a must, even if you live right next door to the rainiest spot on the map. And this isn't just history. In the remote village of Gendathur in Karnataka, regular citizens took matters into their own hands. Nearly 200 households installed rooftop harvesting systems and turned things around. Together, they successfully harvest a massive 100,000 liters of rainwater every single year. So, nature perfectly recycles our water through the hydrological cycle. It's a genuinely renewable resource. But with growing populations and crazy demands, the real question is, are you doing your part to catch the rain? As you think about the incredible power of these simple, decentralized solutions, ask yourself how you might apply a little of this ancient wisdom to the modern water crisis in your own community. Thanks for joining me on this explainer, and I'll catch you in the next one.